We're here today to talk about, you just saw a very cool presentation about the integration of AppDynamics and ACI. We're going to take that one step further and talk about how we do correlation and secure your apps across networks and clouds. I'm joined by James Barnhun and Brent Bertzel. They're going to come up later and they're going to talk about themselves. I'm the Director of Enterprise Architecture and Strategy at AppDynamics. So without further ado, let's get going. Okay, so it's no secret that in this day and age, people are more than ever, everybody's using their phones or their applications to actually get things done. You're either buying grocery or you're renewing your insurance. It feels all very easy and transparent when you're using your phone. But in reality, applications are becoming more and more complex from the application perspective or even the networking perspective, right? We're traversing fabrics, we're traversing clouds, we're touching different languages, different types of databases. So it's not an easy world when you look behind the covers of an application. That brings a different side of complexity, that it's not only about the technology, but also the amount of people and different silos in an organization that are involved in operating and maintaining an application. Everyone, if you look at security guys, the networking guys, infrastructure, application, they all have their view of the same subject. So you're looking at an app, but if I'm an application guy, my take of the app is the application topology, the layers, the communication, the components. If you're a networking person, you're looking at the same subject, but with a different lenses. And it's very hard to help the collaboration and communication between all those different silos. AppDynamics is born and built to help the application people reduce the mean time to resolution of an issue, right? So given that complexity, if you have an application and you're having a better user experience, let's say you open a ticket with your bank where you're not being able to make a transfer or you're not being able to make a payment. Basically, when that hits the desk, people were going to try to find out, okay, who's to blame and who's doing what. AppDynamics helps the application people to quickly diagnose where is the possible source of the problem. So we traverse that complexity pretty quickly, and we basically tell you, well, based on what is happening right now, the error you got is due to a database SQL change. That's in a nutshell. So when we were born, we started in the APM space, the application performance management space. But our biggest differentiator as a company and as a BU within Cisco is the ability to take that application deep dive and elevate the abstractions towards user experience and further on business impact. So we can not only help the application guys to understand and troubleshoot their code, but also we help them understand how upstream that is impacting things. So you can see, oh, this broke, but the user experience was this. Your payments, because of that user experience, went down. Therefore, here is the issue technically, right? So we can traverse all those layers. That's what we're really good at. And that's what we call ourselves an application business-centric BU. But what we've been doing now is, as part of Cisco, we're expanding that into other areas. So you just saw, as part of the networking domain, our integration with ACI. We also have an integration with Intersight, our cloud and infrastructure BU. And later on, you're going to see how we're bringing together the security domain into AppDynamics. We're going to focus now, we're going to double down on the networking side. And we want to show you, we're very excited about the integration we have built with ThousandEyes. And that's what I'm going to give you a demo. So what you see here is AppDynamics. If you look at the top, you're going to see there are multiple perspectives on the application. You can see the application itself and the topology, or you can look at the application from the angle of user experience, or only your databases, or only your infrastructure. What our customers normally do is they use those for pinpointing and drilling down on given areas of the application. And they build dashboards that will aggregate all that information towards key aspects of the application. So in this case, you're looking at an insurance app, and at the top, you're going to see business indicators. So this is AppDynamics collecting all that data about the application and rolling up straight all the way to the business insight perspective. So I can see here that my change health, I can see something yellow. That basically means AppDynamics collects all that data and use our ML and histograms capabilities to baseline that info over time. So when something goes yellow, it means it's off baseline. So there's something going on here. And in fact, I can see that my payment values have gone down and dropped completely at 3 p.m. at that day. So something, it's relatively off. From the business side, this is a problem. Right? Our payment inflow has stopped completely. If I go down and look at the user experience, I can see that there is an uptick on response time. So my response time up to 3 p.m. was around 500 milliseconds, and then it went all the way up to 1.5. There's definitely something off here, and I'm trying to figure out what is it. So I'm going to first drill down on that. So now I'm going to go and click on the drill down button that's sitting right here. And it's going to take me straight up to the application perspective of that response time. So it's loading up my dashboard now, and it's going to show you the topology of that particular transaction. So as you can see here, we can see that the transaction starts on the web tier. It flows through my core services tier. Then that goes all the way to payment services. And then payment services is actually traversing the cloud or the network and hitting an external payment processor provider. So this is a third-party component of my service that I'm not quite aware of what's going on there. And I can see on the bottom that the response time indeed went up. That's the chart that we saw before. So what WebD does, it collects all that transaction over time and it scorecards them. So you can see that pretty much half of my transactions, the user experience have been slow. So let's look at those. What can I see there, right? If it's normal, it's okay, but I'm gonna look at the slow part. In here, what you can see is AppDynamics basically is evaluating all that data. And our agent is getting communication from the central and saying, hey, if this is a slow performance, you need to take a snapshot of it so people can do root cause analysis. So we do that every time. You can control that. We're controlling based on the baseline, or you could do that on a timely manner. So right now, I'm going to go and click on one of those, open it up so I can take a look closely at what's going on. Here, I'm looking at the details of that. And you can see that we're saying, well, the user experience is low, and we give you highlights on the drill down options across every node. Now, notice that these nodes could be sitting on same server, but they could be sitting in different servers within the network or in different servers in different network segments. And this guy might be even traversing the cloud to be reached. So for potential issues, we ranked based across all the nodes, we ranked which ones are the possible problem. And you can see here that at the top, I have this call here. I'm going to take a look at that and see what's causing it. I'm going to drill down on it. And then when I drill down, I now have a view of the code. So you can see the entry of the service here, then the whole stack being called. And at the bottom, I can see that there is a call here to an external service, right? Most likely our HTTP call. That is 99.9% of the performance is being spent here. So I want to take a look at that. So now I do see here that it was an external, indeed is the call for my payment service is right here. So that HTTP call is the call for my external service. And that for sure is now outside of my control. So truly, there is something off here. I don't own that service, but the application itself doesn't seem to be to blame. There's got to be something about the network, and I want to find that out. So I'm going to move on and say, okay, application guys are not meant to be blamed, so let's close this up. Is there anything else? So now when I'm back to my dashboard, and this is where we start, in the previous world, it would be, okay, how do I know, is there any other angle that I can have on this? I'm only looking at the application. Can I understand, can I help the application guy understand that there might be something about the network, right? Is it something that I can see? And especially when it's traversing the cloud, how do I know? And that's where ThousandEyes helps us get there. So the new integration allows us to collect data straight from ThousandEyes and create time series correlation with our metrics. So now you're bringing in network perspective from ThousandEyes that traverses clouds and the application perspective, and you're trying to do time series correlation in an easy manner. So you can easily find out, is there suspicious that the network might be involved? And in here, you can see that the external service.
Quick question here, Renato.
Yes, you can. I'm sorry, I should have opened for a question.
Oh, yeah, no worries. maybe you covered this already or are going to cover it, and I apologize if you have covered it, but
No problem.
how is this information collected? Is it net flow? Is it agents on servers? Is it packet captures? How is this being collected?
Very good question. I'm going to hit ThousandEyes now, and I'm going to pass up to James, and he will give you that answer. How about that?
Sounds
good. Okay,
sure.
So James, you start answering the question when I pass it up, by the way. But that's a good question. I can tell you the tip of the spear, and then James can drill down. But basically, with ThousandEyes, what we do is we set up monitoring, almost like synthetic monitoring capabilities, and they collect that data. And what AppD is doing is reaching ThousandEyes and say, hey, what you see the blue line here is the AD insurance production, and that is my external service. And this is a network, this is the latency of the network. So sure as hell, as my response time went up, I got latency going up too. And I want to drill down into that. So I now want to have a conversation with the networking guys. I'm basically going to go and click on it and jump straight into ThousandEyes at the moment, right, in the correlation that I'm seeing here. So there might be networking here. Let's go and click on the link now. And that takes me to ThousandEyes. And with that, when I land in ThousandEyes, I have a view of the latency, and I'll hand it off to James so he can walk you guys through what we're seeing here. Go ahead, James.
Bruno, good question. I'll talk a little bit about how that works through this flow. But in general, we have agents, which really are points of presence, either owned and operated by ThousandEyes or what we call enterprise agents, which can be installed on a customer's environment. That run either TCP, ICMP, or UDP probes in between either two agents or potentially an agent and a server that allows us to kind of track these network metrics through time. And I'll walk through kind of what that looks like here. So as you can see, we are in the ThousandEyes platform. And what we're doing is running an HTTP server test against this API payment processor that Renato showed on the AppDynamics side. So this is our internal API payment processor. We're running a test against it. And you can see, if you look at the map view here down at the bottom, we're running this against several different points of presence globally, several different agents. Some of which are owned and operated by ThousandEyes, which we call cloud agents, as you can see here in Virginia and San Francisco. And some that are enterprise agents. In this case, we see the AD insurance production enterprise agent that is sitting in our application environment that's hopefully going to allow us to root cause the problem here. As we move to this network view, you can see there's a spike in latency across several of our agents, mostly in the United States, as you can see here in San Francisco and Virginia. But the main problem is our agent that is sitting inside our application environment that has this huge spike to 414 milliseconds. And this is the root cause of the problem. So in order to deep dive and figure out what the issue is and how do we solve it, I'm going to go to a previous point in the timeline to see when things were at a steady state, when there wasn't an increase in latency, to understand what we look like in a steady state. So if we go to the path visualization, you can see a really powerful view here within ThousandEyes, which shows us how this data is traversing the public internet. So on the left-hand side, we have our agents that are operated by us. And then on the right-hand side, you have the front door of the API payment processor. Now, if I increase the number of hops here, what I can do is get a better picture of how this data is traversing the public internet. And each node here represents a hop that this data takes in order to get to its destination. You see here, all of our United States agents are running against an AWS East instance in Ashburn, Virginia. And our London and Tokyo agents are resolving against an AWS instance in Singapore. And this is a classic GeoDNS implementation where, depending on your IP address, you're going to resolve to a different location in order to increase your performance. So this is what the steady state looks like. Everything looks normal, latency is fine. But now let's look at a time when we see a latency spike and see what's different. You can immediately see that there's a change here. Now, all of our instances, including our United States instances, are resolving against the AWS Singapore instance, which fundamentally breaks our GeoDNS implementation and is the root cause here of our huge spike in latency. Why would an agent that is running in the western part of the United States resolve against Singapore instance? This doesn't make any sense. So we've root caused the problem. Normally, this may take a big war room with 20 people in order to figure out what's happening. But here with AppDynamics and ThousandEyes, you can root cause the problem within 5 to 10 minutes. And what we can do is create a share link. That's a really powerful tool within ThousandEyes. And what it is a read-only representation of this data that you can share and send to anybody either within ThousandEyes or outside of ThousandEyes in order to help solve the problem. So in this case, we can take this share link, send it over to our application team, who can then send it over to the API payment processor vendor to see what's going on in order to solve the problem.
So obviously we saw in the dashboard that there was an increase in latency, and we saw that being monitored in the charts that were in ThousandEyes as well. I mean, and this is an awesome demonstration of getting to that root cause. What would actually be alerted out of AppDynamics? So it's monitoring an application, and obviously something has gone badly wrong and gone crazy from thresholds. Would I actually get some kind of alert saying, "Hey, one of your apps just went crazy"? And is there enough intelligence in AppDynamics to be able to say, and by the way, we've traced it down to a network component, and by the way, it looks like it's this. So we're at that stage of correlation in the app.
That's a good question. So yes, what you would get is you would get an alert. We basically create what we call health rules. They can be created automatically based on how we learn the baseline of your application, or you can go and custom create yourself, and then you can traverse metrics and decide how the health rule is going to behave. Sometimes it's not one metric, it's a combination of metrics, but you can define. So it starts out with an alert saying, hey, your payment went down by this much. With that, you can basically jump straight into AppDynamics, into the time frame that happened, and you could pull up that dashboard within the same time frame because the time context is constant in AppD. Mm-hmm. So you set the time and you start flipping. So basically, you could go and exactly do what we did here for root cause with the alert. So instead of just looking at it, I will get an alert, open the alert, and that would take me straight to the time frame that I want to see. And that would help me do the root cause analysis.
Yeah, I mean, what would obviously be great is something where it's like that next step is rather than having to kind of go through, hey, let's look at this transaction, and then, oh, this bit looks big, is you know, if you have the deltas of, you know, what the baseline is for the elements in that transaction, and it's doing a lot of them, is that, well, you know, the baseline for that last element of the transaction, which is the handoff to the HTTP to the third-party payment transaction, payment processor. That one's the one that's gone off the rails. Is you really want the alert to be, hey, by the way, this element of your code, this handoff, that's the thing that went wrong, and that's the alert you get. So you're immediately alerted to, this is the element that's got a problem, and you're directly at it. Rather than, this is always the danger with management systems, is they become a fishing trip, and they're a little rabbit hole to get.
I know.
You know, you spend all day finding things wrong.
That's an extremely fair point. So what you're going to see is that when you're creating those health rules, you could be more specific about the granularity, right? You could see for the application, like I can say application performance overall, but I could also say, oh, you see these third-party services? I really want to watch out for them. So I can set the rules to focus on elements of the app.
Cool.
In this case, I showed you a one that shows everything, but the alert could be, I only care about the database layer because I know there might be some problem there, or an external service. You can control exactly what metric, and the granularity goes as low as any part of the application you manage. So yeah, you could go. Okay. That's the intent of AppDynamics overall, is to remove the noise. So it all depends. In this case, it's what you show. You can go down, 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 but in reality, it could be laser focus and get the answer.
I will also add that you can run alerts inside ThousandEyes, and we have an integration with AppDynamics that will actually send our alerts over to AppDynamics and say, this test that you're running against your API payment processor, we see a really big spike in latency, and so you can kind of root cause it that way as well.
Oh, okay. That's cool. So you can then trigger it back and say, by the way, this is probably impacting these services that you're monitoring in AppDynamics, and raise it from the bottom upwards almost.
Yeah, you can go bottom up. Absolutely. That's a fair call, James. Thanks. Yeah. All right. So let's just close up with how we set that up so you can see how easy it is for us to integrate the two of them and see that working. So what you're going to see here is, okay, how easy is to set this up? I'm basically going to go into my dashboard and I'm going to edit the dashboard. And you can pick a widget, and then you can see on the bottom that we have two metrics. One is backends, and the other one, okay, the source is ThousandEyes, I can basically bring in any of the types of transactions that ThousandEyes can monitor, the probes that ThousandEyes have. Within a probe, I'll pick the given metric I'm interested in. In this case, I pick a network agent. So I'm picking latency. You can see jitter there. And then I basically decide how I want to group them. Do I want to group by test? Do I want to group by agent? And I pick the test. In this case, I'm picking the API the payment processor, and hit OK. So the same way I did that, James would set up the alerts back saying, hey, inform about this service. So we would get the alerts here in the dashboard. You could see the alerts popping up in the dashboard if you want.
About the back end, how is the indexing of all this data done? There's a lot of different data sources there. Being able to correlate those all together, can you talk for 30 seconds about how that's done on the back end and how that stays fast?
That's a good question. So basically, we have different stores. So we have a metric store that should be pretty damn fast for doing those things. So when you're getting here is our backend is collecting the data, storing the data in our metric store, and that's what our dashboard is actually querying to show. In the case of ThousandEyes, we don't even store the data. We can fetch the data straight up from ThousandEyes.
Okay.
So we cache. There is all caching mechanisms and things like that to make it easy, but we basically go back to ThousandEyes and fetch the data straight. We're not ingesting the ThousandEyes data in this case.
That's interesting. So basically what I'm hearing, read between the lines here, is that this front end is the client to multiple APIs.
Yes.
Okay.
Yes,
Very
basically.
cool. Thank you.
You're welcome.
Thanks, Renato. Hey, everybody. Randy Birdsall. I am the product manager for Secure Application, or the official name, AppDynamics with Cisco Secure Application. I'm going to go ahead and just get right into it. This is the familiar view that we've been showing you over and over again, and it's an important because it's kind of foundational to how AppDynamics is approaching how we are providing full stack observability to applications. We've built our business on understanding the business impact, application performance, end user experience, and now we're starting to layer on these other parts, right? We just talked about what we're bringing to the table with the ThousandEyes integration, but we wouldn't be entirely full stack observability if we didn't bring security into the picture, because it obviously has an impact on availability, on the potential for end user experience, in addition to all of the security related things like data loss. So what are we actually doing here? I'm going to get a little bit into how we actually implement and make magic happen. We have the APM agent that helps provide back all of the telemetry that built out those beautiful maps that Renato was showing, that shows all the different microservices communicating to each other. Those APM agents are actually inside the application. So when a customer builds their app, they will either include a library, or in the case of Java, they will use a command line argument to load a Java agent. And that Java agent would be our APM, or Application Performance Management agent. And that has existed for a long time. In the case of Java, we use things like bytecode instrumentation to get code level visibility. Like, we understand what data is going in and out of every single method within that application. Now, from a security perspective, that's kind of data that we've never had access to, right? Anyone who spent time in security, you've always looked at things from the outside in, right? The idea of being able to see what's happening inside the application based upon some event, some data that's being passed to it, is rather unique. We had to rely on the idea that the dev teams put in the appropriate logging and metrics collection. And typically that didn't happen, but it was happening for performance because that was something that was prioritized. So what if we took this instrumentation that we already have inside the application and start using it for security insights? A lot of what we needed was already there, right? We had access to the data going in and out. We understood what methods were being called, but we didn't understand other things like, were there vulnerabilities in the application logic that you were using? Were you not putting in the appropriate HTTP security headers? Were you using vulnerable libraries? Was someone doing something potentially malicious based upon the application's normal behavior? So we added a few more insights and additional telemetry that we were gathering from these applications right there inside the APM agent that's already deployed to thousands and thousands of applications today. So as people upgrade, they'll start to inherit the security capability and be able to turn it on with the flip of a switch. Once they do that, all the security telemetry will start being sent back to the AppDynamics controller, where we'll start determining what type of security insights we can gather from that application. What risk is it introducing to the business? And then help both the app teams and the security teams prioritize based on not what's just like seen on disk or seen from an external scan, but actually what's happening within the application itself. And at the end of the day, that helps both teams speed up what they have to do, right? The app teams can focus on the backlog, getting the feature velocity that they need, and security teams get insight into the application like they've never had before. Now, once we had that data, what are the things that we're doing with it? We're primarily focused on 3 areas. One is determining, are we seeing any vulnerabilities inside the application that are introducing risk? That could be through a third-party library, application logic, how you are collecting data about security exceptions in your application. We're gathering all of that information and then bubbling it up and aligning it to the application itself. And that's unique. Typically, when you are looking for vulnerabilities in an application, it's done from the outside. You're doing a scan, you're providing a URL with the vulnerability, but it doesn't get down to, hey, there's a particular microservice that's using a particular library and it's being used in this particular line of code that is making adding some risk. So there's that vulnerability assessment we do in runtime. The next thing we're doing is, are people leveraging vulnerabilities to attack that application and causing its behavior to be abnormal? For instance, is your application spinning up a shell? That's obviously not something you typically want from your web applications or web microservices. Is it opening up a connection to a site that it's not supposed to? Is it accessing files that it's not supposed to? We will correlate those types of events into a single attack incident and then help align that to the application so that you can prioritize how you spend your time and energy on, if you're on the SecOps side, for instance. And then finally, we're creating policy that's aligned to the application itself. So instead of defining policy in a very blanketed and non-application specific way, you can actually align it to the application, the microservice name, providing necessary parameters that are specific to that application, such that we're able to make sure that the policy and the guardrails that are put in place by security actually applies to the application as intended. So before I move into the demo, I'm going to pause. Any questions on what I covered so far? So here we have the flow map view. Renato was showing it before from a business transaction perspective. This is the 30,000-foot application flow map view that we've got currently. And this shows all of the different microservices that are communicating the flow of data. It's showing N+1, so you're seeing your external API usage here. You're seeing usage of databases. And as you drill down, like Renato did into business transactions, and drill down further, you get this visibility that most security folks that I speak to that have already deployed an APM solution don't realize they have this treasure trove of information that could be used, especially during like forensic analysis. Like, let's look back and see exactly what happened during a certain period of time when we think there was some sort of potential for a breach that we need to go investigate. So this alone kind of like gets the security people really excited. Then what we've done is we started bubbling up security events specific to this view. So as you drill up and down through the stack of this application within this flow map, we're going to start highlighting the security events. You can see on the right side there, we've got the security events widget. And that is highlighting to the person who's looking at this, the IT ops or app ops person who's triaging the health of the application. They're saying like, hey, in addition to the node health, transaction health, there's also your security health. And in this case, we can see that there's obviously some security issues that they want to go and start triaging. So they'll follow through into this view where they'll see all of the vulnerabilities that exist within this particular application. Now, these vulnerabilities are seen in production. They are not seen on disk. It's not like we're doing a source code analysis to say, hey, you've got some libraries that are vulnerable, because in reality, they might not be part of the actual application once you spin it up. These are actually vulnerabilities we've seen from libraries loaded in memory. So the piece that is already a huge step forward is these are actual vulnerabilities in the runtime. But two, we're correlating it to the application. So instead of saying, hey, we see this library in this source repo, we're actually able to say it's part of a particular application. And the app teams are going to know, well, this particular microservice in this application is part of a critical business transaction. Therefore, it's going to have to be prioritized. So you've already kind of expedited correlating vulnerabilities and prioritizing just by getting them aligned to the application and tier name that you can see there in the center. Now, we have sorted the list, obviously, from a severity perspective, but there's also something here that should draw the attention of the person triaging this particular list of vulnerabilities, and that are these two icons. These are letting someone know that we've seen an active exploit against this vulnerability within their application. That is the icon there on the right. Now, to the left of that, that's an icon indicating that we've actually seen it in other applications. So we're leveraging a network effect because this is a SaaS offer that we can say, hey, maybe you're not exploited, but there is definitely some proof of concept code out there that's floating around. It's actively being exploited in other people's environments. You should definitely prioritize it on yours. So really great perspective on how much risk a particular vulnerability is introducing based upon active use of it in your environment or others.
You were talking about scanning what's being loaded directly into memory.
Yeah.
Last week, I had the opportunity to watch some Intel presentations where they're talking about fully encrypting memory. How does this product operate in environments like that where they're trying to minimize attack surfaces by encrypting absolutely everything on box, even in running memory? Does that hamper this product at all in any way?
Awesome question. It doesn't, and there's a good reason for it. So it would make it difficult for any type of encryption of memory or of files on disk when you are outside of the application. So workload security-based products wouldn't necessarily know what's going on. They might see a process spin up, they might see some memory allocation, but they don't know what's inside there. In the case of what we're doing, we are actually part of the application. So we, just like the application sees all of the data it accesses and uses, we see all of that same bit of data. And that's already, what APM has been doing. And we are just now leveraging that insight for security. So for us, it doesn't actually matter whether it's encrypted or not.
Cool, thanks.
Yeah. All right, so here we can see this particular vulnerability. We give us some description of it. Obviously, it's not a good one. It's for remote command, arbitrary remote command execution into whatever application this particular library is running in. And that's an important piece that I just mentioned here. Is we're not just calling out the vulnerability exists, we're showing where it is and what is introducing that vulnerability. In this case, it's this particular library, the struts library. So we've already kind of reduced the time in the investigation that the AppSec teams would have to do or the dev teams as they wanted to remediate this problem.
I got a question for you around that.
Yeah.
So in looking at the vulnerabilities list and the report that you just had up on the screen in the previous slide, do you guys have this formatted or is it on the radar to do this in context of a compliance standard, since we were talking about payment processors? If I wanted to turn this over to a PCI auditor, do you have it sorted in such a way that I can show how these vulnerabilities affect the different areas of a specific compliance standard? Or have you given any thought to that?
Definitely given thought to it, but we're going to be focused on what's currently in product. Maybe we can have an offline conversation about how you might see that coming into the product, and we can talk about where we're going to take it.
Okay, cool. Thanks.
Yep, sure. So now we've narrowed down where the problem is, what's introducing it. Remember, we've got that indication that there's actually been an active exploit of that vulnerability. So if we dive into that specific incident, here we start giving some more visibility, like this next layer down. And this is where you start seeing like SecOps people get in there and say, how bad is this particular attack? What data did they access? And we do a automatic correlation of attack events into this incident to help save some time, so there's not fishing through logs for those SecOps folks. We boil it down into basically the idea of what the methodology would be for that attacker. So if they're leveraging particular vulnerabilities, a series or string of attacks across different components of the application, we'd correlate that here for them. And we'd start sharing some information that you wouldn't normally have access to unless your app teams had done a lot of upfront work to make sure they're collecting the right logs and details from the application, which often isn't the case. And those details are per event on the right side. I like to call them our superpowers. We identify the vulnerability that exists within that particular event that was leveraged, and the particular method that was leveraged that was vulnerable. Here, if we click on the details, you'll see that we actually have visibility to what that attacker was trying to do. In the case of remote code execution, we can see that they were trying to take a look at Etsy Shadow. So obviously that's sensitive information on the underlying operating system that you would not want to expose. And in this case, if they could do that, just imagine they could probably do anything within that operating system. So we give that visibility to not what the user input or data provided was, but what the resulting action was. And that's really important. We also, the way that we've instrumented this, we get it whether it's blocked or not. So you have an understanding of the methodology and the targets that these people are after, even if we're blocking it, because we stop it right before we take that final action once we understand what they're doing. All right, and now that's great information when you're doing your forensic analysis. You're trying to determine how serious of a breach this was. What kind of mitigation do you have to put in place? Do you need to quarantine the workload? But that's one perspective, one angle of it. The other angle is you need to remediate it. So if we take a look over, we also provide a stack trace that's right there below the details. And the stack trace is what the dev team is going to need to understand to go and actually resolve the problem specific to this microservice. And the stack trace, for those that aren't developers, will give you a complete call path through the application. Where did they enter it and where did it exit? And what we've done is actually highlighted where the line of code is that actually the vulnerable method is being leveraged. So they know directly where to go. So we've shrunk the time down from exactly what application is vulnerable, that's been attacked, what microservice, what library, what is the vulnerability, what's the line of code, and what did they actually, what's the data they touched. Like that all in one neat little package totally reduces the time to figure out what's going on. But to resolve this actual problem, to fix it, the dev teams are going to have to make changes to code. And they've already got a backlog, and they have a lot of pressure to maintain feature velocity. So you want to be able to buy them some time. And that's where we provide the policy that can be defined to create guardrails for those applications to buy some time. So here you can see that we can define a policy based upon the application, based upon the tier, and what action we want to take. And here, this is specific to the attack policy for remote code execution applied to that particular application that's being attacked. So once this policy is put into place, it's actually automatically pulled down by the agents that it applies to. And without any downtime, without any blip in performance, without stopping to service any requests, we actually start to now enforce that new policy. So the app teams have some confidence that they're not going to disrupt the expectations around end user experience that they've got or performance, but they also know that they have the time necessary to figure out how do they actually remediate the problem the way they need to. Now, anyone who's gone and updated a library before on an application understands that it can be a huge undertaking, especially if there are significant changes that require like a refactoring of your app. Maybe you have to leverage new APIs within this library. So we want to make sure that they're spending the time on the libraries that matter most and the ones that give the biggest return on investment while they're being protected from that policy. So we'll give them a list of all the libraries that are actively loaded in memory, part of the application, not just sitting on disk, and give them a risk scoring and align that to the component within the application as it exists. You can see here that the struts library that is actually part of the vulnerability that's being leveraged has the highest risk that's being introduced into the application. So this is where the app team should focus their energy first. And if we dive into the details for the specific library, we will get visibility into all of the vulnerabilities that are in that library, in addition to how do you want to remediate those particular problems? Because knowing that it introduces a lot of risk is one part of the puzzle. The next part is, what do I do about it? You can go and do your own research, or we make it easier by saying, hey, for this particular vulnerability, you can see through this whole list, we'll give you exact remediation steps for each one of them so that you're targeted, you're focused, and you're introducing the least amount of churn to your application and getting those problems resolved. So if you think about each step along the way for this demo, we've helped out the IT ops and app ops to find out where the health issues are from a security perspective. We've helped SecOps do their investigation to figure out how bad attacks are, what kind of data was accessed, what were they trying to do. We've given stack traces to the dev and AppSec team so they can fix and remediate the problems quickly. And we've given them guidance on where they need to prioritize reducing their risk exposure for those third-party vulnerabilities in actual runtime instead of just sitting on disk. So huge time savings across the board for all those personas.
Do you see issues with false positives with some of these risks, or are these always legitimate risk?
So there's always a chance for false positives. No security product will ever be perfect. I don't think any vendor would ever claim that. So yes, there's definitely a chance for false positives. The difference in the case of like these vulnerable libraries is we actually know that you've loaded these into memory. We see them actively part of the application. We know for sure that vulnerabilities exist in these libraries. So the chance of a false positive on these vulnerabilities is very, very low. That would probably be a bug more than anything. On the attack front, actually, let me finish up on that. You could have a mitigation in place that you're doing somewhere in the perimeter, maybe in your workload security. There could be some other mitigation in place that reduces the risk for this particular vulnerability in a library, but that doesn't mean that the risk doesn't exist within the application. That piece of it is going to be true. On the attack front, applications are moving so fast. There's such a high rate of change. There is a chance that your application behavior has changed, and the policy doesn't adapt or understand that change, and that could generate some false positives. But we give the ability and view into exactly what's happening for all of those events and ability to tweak and adjust those policies as necessary, in addition to the modeling that we're doing to automatically recommend policy.
And so it kind of sounds like this requires a lot of care and feeding because applications are changing so rapidly. So someone who's always got their eye on the dashboard and checking things.
So that's actually the beauty of being in the app. We already know what the app's doing by being in the app. So we can see what the normal behavior is. We can see what's actually been introduced. And these scans and this determination as to the behavior of the application, the vulnerabilities, happens the moment it spins up. So you push out a change goes out into production. The moment it starts up, we're sitting there watching for that behavior and understanding the vulnerabilities that are there. The moment that you resolve it and you push a fix, we'll automatically detect it. So these vulnerabilities will automatically handle like status management. No one needs to do anything. From the attack protection side with the policy, if you define a policy that says no one should do remote code execution, no one should be able to start up a shell process from within these apps, which is almost a universal truth, you set that policy and forget it. You could set it across all of your apps and just have it take effect. So the care and feeding is something that we want to remove all friction. In a perfect world, they don't have to touch anything and we just protect them. And the product will continue to evolve to foster that frictionless adoption.